What's up everyone, this is LeetCode 542 01 matrix. We're doing this in C++. We've done this in Python. I'll be honest, the C++ solution is a little bit more verbose, right? It's a little bit more wordy. So if you're just trying to wrap your head around this problem, I recommend the Python video, but if you just want a C++ solution, then you can watch this video. So we're given an m by n binary matrix mat, right? And we have to return the distance to the nearest zero for each cell. And the distance between two adjacent cells is 1, right? So basically what we have to do is we find, for each cell, we need to find the near, well, first of all, the cells are either 0 or 1, right? It's a binary matrix. And for each cell, we need to find the nearest 0 and return that, and do that for each cell and then return the output, right? So for example, the nearest 0 to all these zeros is just 0. For this 1, the nearest 0 is 1 away. So the input is the same as the output for this example. This example though, right? The nearest 0 to 0 is 0, right? This 1, the nearest 0 is 1, the nearest 0 is 1, the nearest 0 is 1. For here, though, the nearest 0 is 2 away. You cannot go diagonally. It's only 4 directional, up, down, left, right, right? So you can go here, you can go here, you can go here, you can go here, but it's 2 away in each case, right? So this cell here is a 2, actually. The nearest 0 is 2 away, and you can see that down here. And these illustrations are only for the inputs, right? So it doesn't show you the output. You have to kind of visualize that yourself, but yeah, it's basically what we're doing. It's not too difficult to understand the actual problem statement. The implementation is a little bit more tricky, right? And what we're going to do in our approach, okay, is we're going to iterate through the matrix, and when we encounter 0, we're going to put that the coordinates of that into our queue, right, that we're going to maintain, right? Go here, this is 0, 1, right? And we keep doing that, okay? We're going to keep doing that. I don't have enough space for all the zeros to put it in here, but you get the point. Okay. And when we encounter a number that's not 0, namely when we encounter a 1, right, because it's a binary matrix, we're going to replace it with -1. Okay. And these are just placeholder values, okay? And what we're going to do is we're going to pop from the queue, right? And really, again, we added the coordinates, so we're popping the coordinates. So we get 0, 0, right? When we pop from the queue the first time. And so from here, what we're going to do is, right, this would be the first coordinate we pop right here. We're going to go 4 directionally from where we pop, right? And what we're going to do is we're basically going to check, okay, are we in bounds in the matrix? Okay, and if we are, have we encountered a -1? Okay, meaning a placeholder value. And if both of those are true, we encountered a placeholder value, and we're in bounds. We're gonna take the value of where we came from, and take that, add 1 to it, and replace the current placeholder value that we encountered, and add the placeholder coordinates to our queue. Now, we wouldn't do this in this case because this is a 0 right here, but let's say this was a 1, right? What we would do is we'd take the value of 0, add 1 to it, we get 1. Well, it'd be -1, sorry, not 1. With 0, right, we add 1, so we get 1, and we replace this -1 with 1, and we add the coordinates here, okay? And the reason we need to add the placeholder coordinates is because, like, if we're here, for example, we want to make sure we handle this point here, right? And the way we do that is by adding this to our queue, right? So we go forward directly from here and actually hit this point right here. Because again, initially we only add the zeros to our queue, okay? So yeah, that's kind of the gist of how we're going to handle the problem, okay? So let's do this. What we're going to do is, first of all, we need to get the length, right, of the actual matrix, right? So we're gonna say mat.size, right? We're gonna get the columns. I'm gonna say this. Okay. And we need to make our queue, okay? And again, for our queue, we're adding the coordinates, right? Which is why we have to do it like this. Okay, hope that makes sense. Now let's make a vector, right? And this will be for the directions, right? So we're gonna go 0, 1. We're gonna go 0, -1. We're gonna go 1, 0. And we're gonna go -1, 0. Okay. Now, now we need to do the thing where, oh sorry, r less than rows. Now we need to do the thing where we add basically zeros to the queue. Okay. So, we need a nested loop. Okay. So we're gonna say for int c, c is less than columns, c++. So for here, right, if we encounter a coordinate point that is equal to 0, we can just push that onto our queue, okay? And again, we need to push the coordinates, okay? Else, what we're going to do, and the else, again, this is a binary matrix, so the else really is just when it's not a 0, but the only other case would be if it's a 1, because it's either a 0 or a 1, it's not anything else. So in this else statement, it would be a 1. So that's the part where we set this to just -1, right? Which would be like our placeholder value, okay? And let me just, I don't write the prettiest C++ code, as you can tell, but I'm just doing this I'm doing it this way just so it's a little bit more readable. So now we basically iterated through the matrix, okay? And added what we needed to and set the placeholder values. So now we're gonna iterate through the queue, okay? So we need to get a pair. We need to get a pair of integers. And now we need to go forward directionally from that pair that we popped. When I say pair, really, I'm talking about the pair of coordinates, right? The row and the column, right? So when we pop that pair, we need to go forward directionally, right? So when we pop this 0, 0 from here, we need to go forward directionally from there. Or when we pop this here, we need to go forward directionally from here, right? That's what I mean. So we're going to say the direction from here. Right, and we would do, for row, we'd do dr plus row, right? For column, we'd do dc plus column, right? And again, like I said, this is a little bit verbose in C++, but it's a little bit more readable in Python, I think. But it's okay, not a big deal. So we're gonna say r is less than rows. Whoops, rows and 0 less than or equal to c. Okay, so we're in bounds, right? Remember the two conditions? We need to be in bounds and we need to hit a placeholder value, right? So we need to say, and we need to, when we go forward directionally from a given point, right? When we pop from a queue, right, a given point, we go forward directionally, we need to be in bounds and we need to hit a placeholder value. If we hit a placeholder value and we're in bounds, then we can actually do something, okay? And what we would do is, again, we need to add it to the queue because it's that placeholder value is important, because if we hit this one here, right, we need to make sure we handle this here. That's why we add this to the queue. Okay, so we put this to our queue, right, if we were to hit something like that. And on top of that, we need to change that placeholder value to where we came from plus 1. So where did we come from? We came from mat row call. So we would say mat row call, right, plus 1. Okay. And then again, at the end, we got to make sure we actually return, okay? I feel like I didn't explain nearly enough in this video, but I will double back here before I end. Okay. All right. Again, sorry, I didn't feel like I talked enough this video, but I just need to make sure I don't have any errors in my code, right? C++ is a lot more picky than Python. But again, what we're doing, right, is here we're just doing the setup, right? We're getting the rows, the columns, we're creating the queue, the directions. And then here what we're doing is we're just iterating through the input matrix. And if it's a 0, we're adding it to the queue. If it's a 1, we're setting it to -1 because that's our placeholder value, okay? And here we're popping from the queue, okay? So the coordinates for these zeros. And when we pop from the queue, we go forward directionally from there, okay? And if any of the when we go in a particular direction for any of these pops, right, in the queue, if we're in bounds and we hit a placeholder value of -1, right, then what we need to do is where we came from forward directionally, we need to take that value, add 1 to it, and put that wherever that placeholder value is, okay? So for example, when we go here, we hit this -1, right? We add 1 to the 0, so we replace this with 1, okay? Now, when we're here, for example, we go forward directionally and we go down, this will be -1, right? So what we would do is we take this 1 here where we came from, so the value would be 1. We add 1 to it, so we'd get 2, and we replace that placeholder here with 2, which would make sense because that's what we expect, right? And we put this in our queue as well because, maybe there's something below or whatever. So, that we need to handle all the cells that way, okay? So that's what we're doing. I don't think it's too complicated. Don't get confused by like these variables here. This is basically just adding, like here what we're doing is we're taking row, right, and we're just adding 1 to the left or 1 to the right. This is basically just for handling what direction we're going, right? Are we going up? Are we going left, right, down? Right, that's all we're doing here. So don't get confused by that. And then, I've said this before in the Python video, like this problem was a little bit hard to wrap my head around the first time, but now it makes a lot of sense. So I really would just, make sure you understand what every line is doing, and try to like think about this problem in terms of what are you doing step by step, rather than trying to understand the whole problem at once if you're struggling with it, because I think if you try to understand the whole problem at once, it can be a little bit confusing. But yeah, there is another problem that we're going to do that is similar to this one. So if this one was hard, don't feel too bad. But I hope this helped, and I'll see you in the next one. Peace out.